what are the features, what are the limitations, and what are the fine print over there. They say do never run in production. That's what it says. Even Superbase's website for Postgres MCP server, it clearly says do not open up to like your production database. Do it on dev and test. What that means is like, okay, then our usage for the MCP servers are extremely limited in that case. I have presented a couple of AI DBA talks recently with ClickHouse. We experimented ingesting our alerting data into ClickHouse, attaching that ClickHouse instance locally to MCP server to LLM, and it's actually, the results are much better, productive and non-invasive. It doesn't reveal anything. You can also do basically mask the data, create a materialized view table, and then read it from there. It won't go any data will not be leaked outside. So you can actually put some breaking points. Okay, I think we can get started with the today's talk. Thanks for the intro. We've had extra minutes. This talk is kind of long, so we will have the second part so that more interactive, and hopefully we'll have some demo to it. Okay. So my name is Alkin. I'm the director of services at Altinity. Altinity, we focus on mostly ClickHouse and ClickHouse ecosystem. We provide SaaS solution, support and services and I'm responsible from the services, which I run the global support team. And we also do development and patches, updates to ClickHouse ecosystem. And this also comes with a lot of the other open source users from the market ingesting their OLTP data from MySQL and Postgres into ClickHouse. So we are actually still part of the open source ecosystem. And René is my co-speaker today, founder and the CEO of ProxySQL. Everyone hopefully in this room already knows René. We don't need to go into details. And that's where we start from. Okay, today there is no sailing trivia, my usual icebreaker. We will move on to the agenda. So our agenda is the ideas of what I mentioned about the vector search, and the MCP evolution within the less than a year actually. Things moving super fast. And one thing I also want to mention is we this year, in the last 6 months, as also mentioned in the previous talk, adopting to the AI-based development in production. Like for our product and services, we are actually using AI. So the ideas are all developing. Our context for today is going to be the MySQL with the vector, which actually ties up to the ProxySQL ecosystem and how to manage the whole thing as one piece. And so there's a prototype plugin for the vector, and then ProxySQL control plane. These are all design discussions. Again, we've been actually working on this very recently, let's say a couple of months, specifically making to this event, to get it ready until to this event. So it's not like a years long of work. It's basically mostly doing that very recently. So here we have AI queries. So again, we have a lot of data that we want to actually utilize. Of course, the data is already being served by the databases. We don't actually need that. But what we actually necessarily need for this new era for the AI is more correlation, and that actually ends up with the search. So the point search or the other search techniques and algorithms did not go well with the new era of data. So that's where the whole idea is from the vector. We have the embeddings and similarity search and the workload. We'll dive into that a little bit. I'll do a quick refresher on that. And of course our MySQL as our system of record. So we are already tied into the MySQL ecosystem, and going into something else will actually be an additional overhead and learning curve. So if you can do all of this where you're already familiar with, maybe 5 years, 10 years, and 2 decades into it, it would be a much easier solution. Again, just a refresher over here, MySQL or other variants of these open source databases, Postgres, ClickHouse, anything else, that they're not a vector database. They are actually a vector store. They can be used as vector store because we can actually ingest in basically the embeddings as a string, as a binary, or some sort of a data type that we can actually ingest it into the database. So we just need to remind of that. The typical pattern over here is we have the MySQL as an OLTP. There should be running some sort of embedding service because these databases are not designed to encode embeddings or decode embeddings. Basically, they're designed to do regular data operations. And we will need some sort of an embedding service external. So this idea evolves over iterating over what are the needs for this whole ecosystem, and we come into the single control plane. So I think discussing with René over the course of the months, if we can operationalize these embeddings and the orchestration, we can actually carry this operation into the proxy layer. So we also already have the OLTP stability. We know what we are doing with our database. We can extend, add, remove modules. That was in the first talk. As you saw, it actually expands to including an MCP server here, as well as actually enhancing the full text search and combining with the vector search into this. So this will be pluggable storage. And there are more ideas, of course, needs to be experimented. We have a lot of developments in the data lake area. Object store, S3 compatible storage are becoming cheaper and comparatively. So this type of data can be also extended and used within this ecosystem. So we can have another module that can read, iceberg Parquet files and then basically operationalize them over here. And the idea is open for development. So this is what the talk's subject is, where ProxySQL meets with the MyVector. So ProxySQL we already know. It's been almost the de facto standard for on-prem or cloud installations in MySQL ecosystem. And adding a vector data type that came with the MySQL and the distance functions also, and other searches that will be operationalizing in the MySQL ecosystem is our idea over here. So let's do a little quick refresher over here. Why are we talking about this vector and vector? So we have a lot of objects. These objects are not the regular data types, as most of you already experts over here that you know. These are the more complex one. It could be a voice. We saw some examples this week with the cloud bot, which is renamed to Moltbot this year, and immediately started a voice agent and voice data processing, and that data can be actually processed somewhere else, and it needs this type of data set. And then those dimensions will increase if it's a video generation, and then they will be represented as arrays. So that's our dimensions and the data. And quick refresher on the HNSW index algorithm. HNSW algorithm is kind of a proven. There's a white paper. There's a library around it. So we're not actually reinventing the wheel over here. This is the technique is being used by many other vector plugins that are already embedded into the AI databases, including the vector database, not the vector stores. There's a list of vector databases that is designed for this type of workload, and basically it is more efficient to do these vector type of data sets in layered, so it can actually reach the nearest neighbor. What that means is not an exact or a point select query like you have the regular primary key or other indexes. And by the way, there is these vector data type that is introduced in MySQL version 9 as a data type cannot be used on those keys. So you cannot use it as a primary key, you cannot use it as a secondary key, you cannot use it as there's a limitation for that data type also, because it's an array. So, so the vector search can actually do the semantic meaning of the relationships, and that could be words, phrases, and other. And it's actually, there's a pre-trained models, and these models also evolved. So if I looked at from the last year's models to this year's, in just 1 year, what happened is they are actually more efficient, they can process higher dimensions, and they are actually faster. And I think I saw something a few days ago. Microsoft also released an algorithm that can run on a CPU, not non-GPU, which is super fast also. So these things are changing almost every day. It's hard to catch up with everything, but as a refresher, the vectors are actually able to, we can actually index them and then reach them in that. So I'm not going to go into too much detail of the MyVector over here, because that was a separate talk we've actually presented a couple of times. If anyone interested, I can send the repo link, documents, and also demos around it, that how this works. And basically, the way that we process the data is to turn that embedding into an index that can be maintained using binary log. So you build the index and then maintain. Okay, the building an index with multi-dimensional is, if you increase the dimensions, it's actually CPU heavy operation, so you need a compute. And so the operationally, we're thinking of using again ProxySQL, maybe another node that can actually do high GPU processing and then store that into a host group of, René will present that actually, another maybe a replica, and then serve this data by routing from ProxySQL. The other way is the vector implementation can be taken out. The vector operation can be taken out, that René mentioned this morning, as an external module to the ProxySQL component of the ecosystem. So you already know there's host groups, primaries, and replicas, and then ProxySQL routes the traffic as it's also there is a query rewriting and other techniques that can be applied. What is the caveat? Only caveat over here. MySQL's pluggable architecture requires compiling as a binary to MySQL, so it cannot be operationalized as an external plugin. So
if you use a component.
If I use
the
a
components,
components,
not the plugins.
yes.
Okay.
So
because it uses lead mine chassis, then in theory it's independent from the server, so you could do that. But it's a plugin, right?
It's a plugin, yes.
Right.
So it needs to be turned into a component. Yes. Okay, thanks for that
we can
update.
talk about it later.
Yeah, we can talk about that. So that's actually one thing, but in the normal plugins, they were always written this way. It's compiled, and compiling and maintaining MySQL binary or a release is not a very easy task. So it's kind of operationally, you have to maintain at least 8, 8, 4, 9 versions and multiple architectures, so on and so forth. So that's a design discussion. Apart from that, if your index is actually, if your data is changing a lot, that those embeddings are actually being produced, generated, so maintenance of that HNSW index will be heavy processing, and so there are some pros and cons. You get something, but you have to give something to around it. What we could do in the search for MySQL wasn't also super efficient. If you remember, I mentioned these in the MyVector talks before. Is we use Solr, we use Phoenix, and other techniques to actually serve the search traffic. So that's where we are. We can talk about this later on again. So going back to the single control plane idea, basically we have the application, we have ProxySQL, and then we can have end points pointing to the vector replica that has the still the set of the same data or a subset of data that can be used. And you can basically, with the query rules, you can basically still serve vector-related data using the ProxySQL. Of course, there is an additional piece to that will be in the architecture is the MCP endpoint. MCP can also utilize this endpoint in this sense. So that is the idea over here. It could be a dedicated search instance that can be actually searching for that using that type of technique in that sense. Okay. So I think we're going to switch over here, go into the ingestion pipeline. And that's how we, should I just plug in? All right, quick change over here. Quick switch. Yes.
Okay. So this is the ingestion. As I was mentioning before, I was going to describe into more detail during this session. So we have the ability of using full text search and semantic search or vector search within ProxySQL. The way it works is that we have currently an ingestion third-party tools. That is basically an application that we developed. What this application is able to do is basically connect to MySQL server, retrieve the data, and import it into ProxySQL itself. The way it works is that let's get into more details. It uses the MySQL protocol, even if it's storing the data inside an SQLite server database, because ProxySQL has also the capability of exporting, of allowing client to connect to his own internal SQLite database server using the MySQL protocol. So from a client point of view, it's nothing more than a MySQL server. This allows us to have this as an initial POC in which we use the embedded SQLite, but in the future we can move to another storage like MyVector. So there's actually a work in progress, and we are planning to use MyVector in the near future. So what this application does is it connects to MySQL server, fetch the data, and put it into MySQL itself. Now, it uses the target database, in this case SQLite, as also a configuration. So the configuration of what data need to be ingested is in the database server. So there is this configuration table called the rack source. There we basically define, and you can define it manually, or you can have an LLM generating it based on its own discovery of the schema. You define what is the source of the data, what is the tables that you need to index, what are the columns that you need to index, what are the chunking strategy, what is the embedding strategies, embedding configuration, and so on. We actually have more details here. Okay, so they ingest connect to MySQL, so to this source, and for each source, because again this is a table, so you have multiple rows, each row represents a source. It reads what is the tables that need to sync, and it also reads what is the state of the sync. So basically the way we implemented the incremental sync at the moment is that at the end of every sync, it basically writes in this table also what is the status of this process. And again, this is our first POC, because later on we plan to also use replication, so this will be way more resilient. Then it connects to the MySQL server. It starts fetching all the new data on the specified tables. Specified tables doesn't not just use the primary key as the watermark, but it also has some workloads. Like for example, you only might want to read data that has a specific workloads, like only question or only answer and so on. So you only fetch those, and basically it iterates and it stores this information in its own embedded SQLite. It performs some transformation during this stage, so I will show them in the next slide, because it just doesn't store the data as is, but performs transformation. Transformation can be splitting the data or also merging data depending from the content. So this is our representation. So in this tables, basically, in these columns, we basically define what to do with the document. So what are the stages? And the stages can be chunky. So if a row is extremely large or larger than what is the size of the embedding, the number of tokens, it is automatically split. It also defines what is the splitting strategy. Like, for example, you want to split in chunks of 8 kilobytes, but you also want to have 400 bytes on each side to be carried over. So all those are defined here. So it is then being digested and pushed into a tables where there would be where we have a full text search index. Next, there is the embedding that is optional and again is working at the moment. So if the embedding is enabled for that specific source, what it does is after it reads the rows, what is the right word? It batches together a certain number of rows, and then it uses this batch size to basically performs HTTP request to the embedding module, and then depending with this, currently we support the OpenAI compatible API. So it gets the embedding, and those embedding is being stored again on the SQLite or in MyVector as soon as we enhance this a bit more. And we iterate until there is no more rows that need to be embedded. We have multiple settings within this RAG source table. That is the doc map JSON that basically define how the transformation need to be performed. The chunking JSON that define how the text need to be split. The embedding JSON that again basically every column has a JSON configuration that defines what to do with the table. In the specific case of the embedding JSON, we define what is the provider, what is the models that we use for the embedding, and the batch size. If you're using embedding, it's very important to remember that you need to use the same model both when you're creating the embedding and then when you are embedding the queries that you want to implement. Currently, we support two providers. One is a stuff just like for testing, and the other one is the OpenAI. So we can use the OpenAI compatible protocol for generating embedding. This is an example on how you create configuration in the RAG source. So RAG source has multiple columns, so the name is arbitrary, and then you have configuration about the type of backend. So in this case, the backend is a MySQL server. In our case, we use SQLite using the MySQL protocol, or using the same configuration, we can use MySQL with MyVector. Then we define the port, the host and the port, what is the table name, and what is the primary key. We can define the primary key, a workloads that will be used when retrieving the data, and then we have the doc map JSON, chunking, and embedding. So all those details are there. In this case, published equal 1, so like whatever, in this example, just a blog post only is going to embed only the article that has been published, nothing else. So once this is defined, you can just run this command, run ingest, and with ingest argument, it will basically does all this automatically once this table is configured. The idea is that once this is implemented within ProxySQL, you don't have to call any external tool like this, and it will automatically synchronize the data on its own. So, as I was mentioning, the way we do the incremental is using a watermark within this configuration file, that is the sync state. So it knows where it left from the previous synchronization. Later on, what we of course plan to do is to start using binary log for this. So ProxySQL will be able to listen to any number of servers, and when data is being updated, is automatically put data into this RAG catalog or MyVector automatically. And it is optimized for batching, so it batches the data batches the data together, so the embedding, it reduces the number of calls to the embedding modules. This is just to improve network overhead, because basically just doing way less call. Okay, and this is the search I was mentioning before. I will go quickly through it. Once you have both the full text columns and the vector, ProxySQL, when the agent is performing a hybrid search, ProxySQL will be able to execute both search at the same time. So it will do a full text search and a vector. We'll combine the result and get the documents and return those documents to the agents.
What is the just additional latency for this? Because it needs to go two routes.
No, well, the full text search and the vector can be either built-in inside ProxySQL or using MySQL and MySQL vector. Of course, if it is an external service, like if the vector is on MyVector on a different MySQL server, of course then you have an extra latency, but it's network round trip mostly. And the idea is to identify what is the relevant data without reaching MySQL server where data is stored. So instead of performing a longer search on the MySQL server, we quickly identify what is the relevant data that need to be returned to the agent.
So this is all inside ProxySQL.
Till here. Oops.
Yeah, that's okay.
That's okay.
Till here, yes. And then you might have, if the content is already inside ProxySQL, yes. Actually here, maybe. So those calls, they all happen within ProxySQL. So ProxySQL has already the chunk, so the chunk can be returned to the agent. But we also have, let's see, where is the slide? We also have this tool. So if instead of having the individual chunks, you want the source, what was the document from which, the row from which all those chunks has been generated, you can request it from the MySQL server. Any other question on this?
So do you have the embedding model internally in the...
Currently, no. But the embedding is terrible. Like it's easier to implement. No, the embedding is easy. The re-ranking is very difficult. The embedding is easier.
Yeah.
Currently, what we have is on the GenAI module. We export an embedding endpoint, so an AI can connect to that embedding endpoint, and then ProxySQL behind the scene will redirect the traffic to an embedding module. But it's quite easy to actually have the embedding embedded inside ProxySQL. So that's probably something that we are going to explore.
So when you do actually, you have the pipeline there where the query comes in, you already have to do the embedding for the query, I guess.
Any other question or?
Can you repeat that?
So there was a slide with the query and then the hybrid search and so on. When you do have the query, you already have to have the embedding for the query, because I didn't see the
Correct.
See that one there.
Yes. So basically during the search can also ask its own embedding.
Correct.
If there is no more question, I pass the ball back to you, and I go back to prepare the demo.
Okay. Okay. Where are we? Let's go with the rest of it. Okay.
We had the
There's a
program.
question here.
Yes. Sure.
So from this architecture, what kind of performance can we expect in, let's say, maximum number of searches per second or per minute?
I don't have a number right now, but the main idea is to reduce complexity and reduce network latency, because you might have the option of having everything packed together, so reducing the latency also with embedding. Like if the embedding is built in inside ProxySQL, like you don't call an external service, it is somewhere else. So you drastically reduce the latency. We don't have numbers, like we don't have benchmark at the moment. Probably something that we are going to work soon. Thanks.
But also, usually the LLM response is quite latency.
Yes.
There's high latency, so the other parts are quite quick in comparison.
Yes, and the idea here is to try, as I was mentioning on the previous call, like the idea is to try to implement as many type of different search there, because that will reduce the chat with LLM. So if, for example, we perform different type of hybrid search, like we do full text search, and in parallel we do the vector search, and then we combine the result. This is one strategy. And the strategy is performing a full text search, getting less number of result, and then on those results only performs the vector search. That's another strategy. Different strategy instead that is not listed here is to perform the re-ranking. So you can do something like full text search, and from the result of the full text search, you re-rank together the request from the LLM together with the output of the full text search, and then you are ranking on them. So there are different strategies that we can run all of them in parallel. So the idea is that if we are able to identify good result as fast as possible, the LLM can be happy with the result without the need for asking for more.
Do you have any concept of using like a knowledge graph and so on as well, or just chunk?
We are evaluating this as well. There is a lot going on. As I was mentioning, as I was showing before, is that we increased the code size by 30% or something like this, just introducing all this, and that's quite a lot considering that we already support the MySQL and Postgres, so there is a lot of codes for that. So introducing all this, there is a lot of moving parts. Javier?
Yeah.
Okay.
Good.
Okay. I'm coming back.
Okay, yes.
Do you want to?
I'll give you.
Yeah. Let me.
Few minutes.
I have a few minutes.
I'm
I had a few minutes from the last deck that I can actually go over real quick, just a recap of where we are. Okay. So, 1 second. I guess this. All right. So we talked about the ingestion and database safety and the guardrails. So one of the things that I actually kind of have experimented with the MCP servers, going to the database. MCP servers, really the protocol or the context doesn't know anything about database or the databases, query optimizations, anything that actually is supposed to be used, it doesn't know. You actually have to guide and try to train it before you can actually open it. So that's another point over here with the database safety. When it comes to embedding and everything that you want to use it for your AI-ready database, you still need to have guardrails. And those guardrails have to sit someplace. It needs to be persistent and evolving. So you should be able to update them. And as we proposed over here, that layer can be ProxySQL to keep those guardrails within the ecosystem. Otherwise, you have to run a very custom MCP server with a lot of limitations and restrictions so that it doesn't do the things that you don't want to. And that's basically where it comes down to when it comes to database safety. Traffic and reliability is also another thing where when you open up your AI tokens or AI usage to the database, it may or it may not be very efficient. So the token usage has become a question. I don't know if any of you ran out of your personal tokens recently. I did. I actually burned through several tokens from several. Ronald actually experimented with the MCP server. It chewed up, like some examples, chewed up the tokens faster than we expected it. So it says, okay, put another $200 to get that. Basically, token usage, efficiency, maybe even compression, caching, and everything else can also be considered into this ecosystem. So that's actually evolving. I have some experiments with the MCP server that I will reveal some numbers hopefully coming months. And security and governance, of course, this will, if you're using in production, then we also start thinking about security and compliance, where we are adding new services or operational plugins to your ecosystem, then those may or may not pass those security checks. So that's another thing to consider. That API surface, that wherever we are actually opening up our database, the backend database needs to be controlled very well with the safeguards. Okay. So introduce ProxySQL as a traffic control point, store embeddings alongside with the data. We didn't mention this whole lot, but embeddings is not MySQL InnoDB compatible. Basically, that's another file in the file system, or you have to store it in somewhere else. And when you create an index, the embeddings are in the database, but the index is not. So sorry, just to rephrase that. So that is an operational risk, and operationally in the production system is something to consider where it's supposed to live. It can be bloated, it can run out of space, or it may not perform well with the IOPS limitations of that storage. And then you actually isolate the host group with that. So this is something we can basically configure over here so that we have the correct database, host group database server that is dedicated for this one, not impacting my production workload. And that's the backfills and tiering can be operated over here. Before I move into that, we have only like a few minutes left. René, do you want to have a demo over here, or okay? Configuration issue, operational configuration issues, and we actually went a little bit out of the way when we started putting this ID in ProxySQL, because we said, okay, while the vector can be living over here, why don't we have the MCP and why don't we have the other full text search? And that made things a little bit more complex than it should be. Otherwise, if it was only ProxySQL sitting in front of a MyVector implementation, it would be just routing traffic to it and from it and getting that. So that prototype already works. And but embedding in the ProxySQL, it made things more complex. Some options over here for the vector storage: single table, easy joins. That will require schema change. Side table, minimal change, but require joins. So, okay. Or you put that on a separate schema. So these are like design decisions, depending on where this is going to be used or what type of data it is. But I like to have a separate schema and separate instance approaches is usually, especially for this type of implementation before you get into the weeds of it. So, okay, SQL with MCP, so this is already covered. I think we can skip that. And observability of that, the matrix. So basically, if you throw the database into an MCP server or just this type of ecosystem without the events or read events, the matrix, it will be completely blind and you won't be able to troubleshoot and basically measure the performance of it. So we actually have ideas around this. So, okay, let's move on to that one. Routing, protection, and governance. We mentioned all of these. We can skip those. I can skip some of these. I don't have the mirroring over here for some reason. I have to look over here. All right, just to wrap up, the key takeaway over here is MyVector will have the native addition to MySQL ecosystem without changing the ecosystem, and the ProxySQL has its own features that already in it. I think query rewrite, query routing are the most keys over here that will be really helpful. And again, the runbooks and everything else can be that can be embedded in the ProxySQL will be interesting factor. We have the repos; they're all open source. The links over here, you can see if you want to give it a try or read through it. There's an MCP server, there's a MyVector plugin, and there's also all the README files and examples. We don't have it over here. So also the ProxySQL, I think the branch is merged. It will be on the 4.0 pipeline for the MySQL, for the ProxySQL. And that's all. Thank you very much. I think this is a long talk. We started even early, and if René can actually show a quick demo around it, it would be really good. If not, we'll have to do it on the hallway.